problem 5E, page 184. Starting from rest, a child zooms out a completely frictionless slide, 100% frictionless, from an initial height of 3.0 meters. What is her speed at the bottom of the slide? We're assuming a mass of 25 kilograms. So, if it is a 100% frictionless slide, what is true about mechanical energy? Nothing is lost. It's an awesome slide. Yeah, it's a fantastic slide. So ME final is equal to ME initial. What we want to know is VF. Okay? So let's look at the two halves of this equation. So first of all, we know, let's look at this piece. We know that mechanical energy final is equal to potential energy due to gravity, final, plus kinetic energy, final. Right? Okay. So, mechanical energy, final. Well, what's her potential gravity at the end of the slide? We assume this goes to the ground. 0. So, if she hits the ground at that point, then this is mass, gravity, final height. If final height is 0, that whole thing is 0. So final mechanical energy is her final kinetic energy. What's the equation for kinetic energy? 1/2 mass velocity squared. And since we're talking about final kinetic energy, that's going to be 1/2 mass velocity final squared. Pardon?
Is her final velocity 0?
That's the moment she stops. Remember, that's an artificial
Why did MG
0.
turn to 0?
Because at this point she's at our arbitrary 0.
Oh, final, yeah.
Yeah, final gravitational. Okay, so our final mechanical energy is equal to 1/2 mass final velocity squared. Okay, does this help us?
Yeah, you can rearrange that.
Are we ready to solve? Do we need anything else?
Do we have the initial sign?
Oh, yes. So, we don't know what this is. Or do we? We do! So let's look at the initial mechanical energy. MI initial is gravitational initial plus kinetic initial. What's the initial kinetic energy when she's sitting at the top of the slide still? 0. Can we figure out her gravitational potential energy at the top of the slide? We can. Okay. So now we have something that we can set equal to something else, which you know we love to do that. Sorry. All right. Is this on screen still if we go over here?
Yeah.
Yes.
Okay. So, mass, gravity, height initial is equal to 1/2 mass velocity final squared. Mass goes away. GH initial times 1/2 VF squared, 2 GHI square root equals final velocity. Okay? So all you're doing in these problems is thinking about what is true about... Pardon?
You just do that so fast, it's just like...
I can go slower if you
No,
want.
no, it's alright, I got it now. It's just-
Okay. I started off going really slow on the algebra with you guys, like doing every single step. By this point in the year, I figure you're warmed up, you're stretched out. Your algebra brain is ready to run that marathon. No?
Kind of cold.
Okay. So, let's plug in some numbers. Square root of 2 times 9.81 meters per second squared times 3.0 meters. Let me ask you a question. Does it matter that this is a slide, that this is an inclined slide? We aren't given an angle.
No.
But she's not going to travel 3 meters. She's going to travel further than that because it's at some angle, right?
Oh, she just. Oh.
Height initial is on.
Talking to the place.
Height is height. Yeah.
She travels 3 meters no matter what angle that slide is
Your
at.
0 point is right at the ground.
But why doesn't it matter how far she travels?
It's
We're talking about displacement, not distance.
Yeah, she traveled the same.
No, the distance she travels will change based on the angle of the slide. It's not even about just displacement. It's above absolute height above your 0. I wanted you to think about that. I want you to be asking the question you're asking right now, you. Because I'm hearing you going, well, wait, doesn't it matter? It doesn't, but I don't want you to take that for granted. When we're talking about gravitational potential energy, we're just looking at height above. Hence the swing problem. Even though we know the path on that swing is going to be different than that straight line distance, we know that the rope is 2 meters out. The amount of fall, the distance above our arbitrary 0 point, does not incorporate path. It is just the sheer distance, okay? All right, so what do you get? What do you get? What do you get?
7.672. 02712.
Yep, 7 points.
The entire year.
The entire year would have finally happened.
We knew it had to happen sooner or later. Okay, so with sig figs we can have what, 2? 7.7 meters per second.
3.
We get 3 sig figs?
Yeah, it's 3.0.
Oh, okay, so 7.67, sorry.
Good stuff in this class. I have to keep going count.
Okay, all right. So, assigned are problems 1 through 5.